Alright guys, so this is part one of a series of videos about organic reactions. And the way this is organized, according to the IB Chem Guide, is to sort of go through the different classes of compounds that you have already looked into and talk about the types of reactions that each of those classes of compounds are likely to engage in. Okay? I'm going to post a version of this sheet that I'm filling in. So if you want to take a second and print that off, if you have that ability, so you can sort of follow along and take notes while you're watching the videos, that's great. If you want to take your own notes on blank paper, also great. Or if you want to just sit and take in the video, whatever works best for you. Hopefully you've got a feel for what's working for you so far in remote learning. Okay, so we're going to start with our simplest compounds, alkanes. And alkanes are a bit limited. We would say that they're not very reactive compounds. There's only a couple types of reactions that you need to be familiar with for alkanes. The first of which is just straight up combustion, which you have seen before. Okay, so this is going to be kind of a review. And a lot of alkanes are used as fuels. We hear their names often, right? Propane can be found in if you have a barbecue that has those tanks at home, then that is a propane tank. Butane, you find that in a lot of lighters. If you have like a portable cigarette lighter, hopefully you're not using it for cigarettes, but those are useful things to have around for lighting birthday candles. And octane is a component of gasoline, okay? And natural gas is made up of methane, okay? So all of these things are fuels that we combust pretty often. And a combustion reaction, pretty predictable. We've seen them before. You have your fuel. So in this first case, we've got methane. It reacts with oxygen to produce carbon dioxide. And because it's hot, the water will be a vapor. Okay? And then to balance that reaction, we just look at the different components. Usually we kind of go by the formula of our fuel, and that allows us to fill in the rest. So here I only have one carbon, so I only need one carbon dioxide. I have 4 hydrogens, so I need 2 waters. And then that gives me a total of 2 plus 2 is 4. So I need a 2 in front of my oxygen. Okay, propane, similar idea. So if you are not able to just come up with a formula of propane, you might want to remember that the general formula for any alkane is CnH2n plus 2. So for propane, I know that it has 3 carbons. So my N in that case is 3. And then my H is, I've got double the number of carbons plus 2 more. So that's going to be H8. Okay. And propane is, let's say it's it's a gas. Under standard conditions, it's a gas. Okay, and then it's going to react with oxygen because it's a combustion reaction to produce carbon dioxide and water. Okay, and then I just balance it out. So I'm going to need 3 carbon dioxides because I have 3 carbons, and I'm going to need 4 waters because I have 8 hydrogens, so that's going to give me 6 plus 4 is 10, so I need 5 oxygen molecules over here. Okay, and then octane, using that same idea of the general formula, I know that's going to be C8 because it's oct, and then H18, okay, because 2 times 8 plus 2 is 18. That is a liquid under standard conditions, plus oxygen gas produces carbon dioxide plus water. Okay, and then balancing it out, I need 8 of these and I need 9 of these. So that gives me 16 plus 9 is 25. So I can balance this one with a fraction rather than having to go back and double every coefficient. Okay, combustion reactions. They release a lot of energy. They combine, in this case, we're looking at the combination of alkanes with oxygen to make carbon dioxide and water. One other thing you should be familiar with, not so much with the balancing, but just with the concept, is incomplete combustion. Okay? Incomplete combustion is what happens when you don't have sufficient oxygen for the combustion to make only carbon dioxide and water. Okay, so if I was to look at something like it's giving me hexane here, so that's C6H14, which is a liquid under standard conditions, and it combines with oxygen, but maybe not enough oxygen, then the combustion will be incomplete. We're still going to convert all of our hydrogen to water, but instead of making only carbon dioxide, we're going to make a combination of carbon solid, of carbon monoxide, and carbon dioxide. Okay? And I'm not going to ask you to worry too much about balancing these reactions, because usually there's more than one ratio that will work to balance it. Okay, but it's more remembering that in incomplete combustion, you get a combination of these three from your carbon that you start with. Okay, and that means, so not all of the carbon is fully oxidized to carbon dioxide. You get some pure carbon soot, and you get some carbon monoxide. And then you'll notice this little bit that I added right here. In most real-world instances, of combustion, a small amount of carbon monoxide and solid carbon are produced. And this is why, it's not super safe to burn things in your home. Okay, do a lot of combustion. For example, if your heat goes out, you shouldn't run your barbecue inside to try to warm your house, because carbon monoxide is often produced. Or if there's something wrong with your furnace and it's not working properly, you need to get it fixed right away, because the incomplete combustion produces carbon monoxide, which is toxic. Okay, but you have probably also noticed that if something lights on fire, there's usually some soot associated with it. Okay, usually there's some black stuff left behind. That's the solid carbon. So that's another indicator that most combustion that happens in the real world is not fully complete. There's usually some solid carbon, some carbon monoxide that results. Okay, let's look at our second type of reaction here with alkanes, the halogenation of alkanes. Now, because alkanes are quite unreactive, you actually, to get this process happening, the halogenation, you actually need to start by creating something called a free radical, which is a very, very reactive species that has an unpaired electron. Okay, and the free radical I'm going to show you is the chlorine free radical. So if you have a chlorine molecule in the presence of UV light, then the bond that holds the chlorine together can absorb that UV photon and it will break. Okay, and this is called homolytic fission, and it results in two chlorine free radicals. And the way we show that they're free radicals is this dot right here, which represents an unpaired electron. Okay, and then having that unpaired electron means that that chlorine atom floating around is extraordinarily reactive, even if it runs into something like an alkane, which is normally not very reactive. So we're going to look at our next page here and see how that chlorine might interact with an alkane. Okay, so the next step, so that step one, sorry, I'm just going to flip back here. That step one is called the initiation step. So the first step in this halogenation is you need to create these free radicals. Otherwise, the rest of the reaction can't proceed. Okay? Our next step is for our free radical to combine with an alkane. And I'm going to keep things simple and just use methane as my alkane. Okay? And what that does, because that chlorine, that unpaired electron, it doesn't want to be unpaired, it wants a pair, that chlorine is going to attack the methane. It's going to take a hydrogen. Okay, so now there's no more free radical there, but it's going to create a methyl radical. Okay, now this is an example of a propagation step, but there's actually all sorts of propagation steps that can happen. Once you have one free radical introduced to a reaction mixture, it can create this chain reaction where just like free radicals are continually produced. So I'll show you another example. If you had your methyl radical that we just made and you combined it, it ran into an intact chlorine molecule, then it could scoop one of those chlorine atoms so that it no longer has an unpaired electron, CH3Cl, and then it reproduces a chlorine free radical, like that. Okay? Now there are a few more examples of propagation steps. You can see them in your textbook on page 485. Okay, so if you want to look at sort of the full set that they included in the textbook, you would find them there. Okay, and then the last thing that happens is called a termination step. Okay, so this is where two free radicals combine, ending the chain reaction. So for example, if my chlorine radical, so this is just an example, there's more than one possible termination step. But for example, if my chlorine radical ran into my methyl radical, then those unpaired electrons could combine to just make a normal single bond, so I would end up with chloromethane. Okay? And now you'll notice I've shown two steps here where this happens. So I've created a haloalkane. Okay? So what you start with your initiation step, which produces these halogen free radicals like this right here. And then when those interact with alkanes, they create haloalkanes. Okay, so you can see the haloalkane I've made here is chloromethane. Okay, but you can make all sorts depending on which alkanes you have in your gas mixture and how many chlorine free radicals or halogen free radicals are present to react with them. Okay, that seems like a logical place to end this video. So that covered the reactions of alkanes. I'm going to post this one today along with a couple suggested questions, and then I will post throughout the week sort of the remaining examples. Okay? Thanks so much for watching, and if you have any questions, feel free to email or comment on the Google Classroom.